I would now request the session chairman and moderator, Mr. Manoj Patil, Strategic Initiatives Lead South Asia, Corteva Agriscience, to join us on the stage. Welcome, sir. Our first panelist, Dr. M.S. Rao, ex-principal scientist in Indian Institute of Horticulture Research. Dr. Rao has 35 years of comprehensive experience in project management and sustainable agriculture. He is a former head and principal scientist of ICAR, Indian Institute of Horticulture Research, Government of India. He was associated with FAO for promoting the use of biopesticides in organic farming in Karnataka state. Welcome, sir. Our next panelist, Mr. Rajat Vardhan, founder and CEO, AgroNext Services Private Limited. Mr. Vardhan have devised an agri-information platform that provides an opportunity for farmers to digitally experience the agri-domain specific products, get their farm-related queries solved in real time with unbiased solutions, recommendations, and on the other hand, connecting farmers to authentic local sellers through AgroNext app. Welcome, sir. Our next panelist, Dr. Naved Sabir, Principal Scientist, Center for Protected Cultivation Technology, Indian Agriculture Research Institute. Dr. Sabir is an experienced management professional with a demonstrated history of working in the research industry. He is skilled in integrated pest management, good agricultural practices, horticulture and agriculture research and development. Welcome, sir. Our last panelist, Dr. Vishal Somvanshi, Principal Scientist, Division of Nematology, ICAR, Indian Agriculture Research Institute. Dr. Somvanshi has the accolade of publishing more than 60 research publications in various national and international journals. His research interests involve in use of insect parasitic nematodes for environment-friendly biological management of insect pests, of crop nematode bacteria symbiosis, and development of novel methods for management of plant parasitic nematodes. Welcome, sir. I now request the chair to take over.
Good afternoon, everyone. Can you all hear me clear? Thank you. So, before we start the session, first of all, I thank Ficci for giving us an opportunity to come here and share our views and understanding on soil health. We have a veteran sitting in this panel, Dr. Rao, Dr. Naved. We have spent almost a lifetime working on agriculture, working on soil health, working on best management practices for improving the productivity of farmer. So in today's session, we want to discuss about how can we manage and improve our soil in a sustainable way. I mean, I was listening to the opening session where we talked about balancing growth and sustainability. So at one end we have to produce the food, and at the other end we need to look at how can we have a soil for the next generation. I'll take a minute to remember one of the story I read when I was studying my agriculture graduation in Pune, and that story says a generation next comes, and the father takes his son to the field, and he says कि मैं आपको ये hand over कर रहा हूँ, I am handovering this to you, and the son goes in the field and says कि Papa, here is the land, but where is the soil? So I mean, we have agriculture land, but what I am saying is deteriorating fast, and we just touch base some aspect of it. How can we manage that? Because it's a very vast subject, and considering the background and experience of the panel member, we'd look at a specific aspect of how as a country we can contribute coming together on improving the soil health. And I request Dr. Rao to just give us a context through a very small 3-minute slide deck, just to set a context what we are going to discuss. Over to you, Dr. Rao.
Good afternoon, everyone. Just 4-5 minutes. I'll just talk about really soil. What we talk about sustainability and all. See, it is a living medium, dynamic medium. It's a living planet that we have actually just because of the life in the soil. So soil is not a soil, but soil has a life. And in my own terms, actually, I would like to say that actually the soil which supports the plant health, animal health, and the human health, is the one actually which is sustainable. So healthy growth, a sustainable growth, and sustenance of all these things actually is dependent on this soil sustainability. So in that particular context, so we in this particular session talk more about the microbiome and so here there are components. So there are components which I call it actually biological and physical. Biological, there are harmful pathogens and there are beneficial microbes. So that we call it as a soil microbiome. And the organic matter actually, I only take it actually the physical component. Rest of things I am not talking because there is an intrinsic relationship between the organic matter and all the biologicals. So the survival of the multiplication and then the performance of the microbes, beneficial microbes, can happen when there is a good amount of organic matter. But that's now in the country actually for the last 70 years we have lost so much amount of organic matter. Organic carbon actually is now around 0.5 to 0.1 1% to 0.3 actually. In most of the areas in the country actually this is a situation. Organic matter is low. This is a situation that we are talking, and because of that, because organic matter is depleted, and you see a lot of pathogens have cropped up, and the plants have become sick, the soil is sick, ultimately the root system is not healthy, so the farmer is dumping the chemicals. This is the scenario which has happened for the last few years. And when you talk about the impact and the adverse effects actually of all these things, we lose almost around 80,000 crores, 80,000 crores actually per year, annually from all these pathogens actually. And these are all the things that you can see. So significant amount of damage is happening. And the new scenario, what I would like to talk actually as a plant protection scientist is that previously, we used to talk about the fungal problems, viral problems, and bacterial problems, nematode problems, separately, individually, predominating the farmer problems. But there is a complex now actually, so which we have understood recently for last 10 years actually. Now we are talking about that. I thank Ficci and I thank Manoj actually. Now the whole context actually, now we are talking about bringing awareness among the people actually. That's a nematode is one of the serious culprit, unseen enemy, which is causing a lot of damage. So along with the nematodes, the fungus gets inside and the bacteria gets inside, the problems are huge. We have the Goa wilt, we have the pomegranate wilt, and so many wilts of the crops actually is a national problems. The culprit is actually the nematode. So these are all the serious problems in the polyhouses. And you see absolutely there is a nematode and there is a bacteria, there is a nematode and then there is a fungus in pomegranate and in Goa, the whole I talk about actually in terms of when we had around that 70,000 hectares actually pomegranate cultivation, which we started actually 10 years back. Now we have only 40,000 actually, hectares. 30,000, polyhouse, the pomegranate actually crops have been taken out just because of the wilt problem. Nematode is the main culprit. This is where actually the problems are happening, and a lot of chemicals are being dumped actually. We need green chemistry, not the indiscriminate use of the fertilizers. See, all these things have happened just because actually indiscriminate use of the fertilizers and the chemicals. The main culprit actually is that people do not have awareness, farmers do not have awareness, and then the farmer neglected actually the organic matter, so there is such an amount of depletion. We talk about the nutrition all the time, NPK, tremendous amount of subsidies actually are being given. Government is spending more and more and is worried more and more actually. We don't talk about the balanced nutrition. So balanced nutrition, where is the, wherein the, microbial, contribution by the NPK solubilism bacteria, and also the, microbes which controls the, pests and diseases, and also the micronutrients. That's not been really talked about that, but then we'll have to think about that, and that is what actually we have to plan it in the future. So we must treat the soil with respect and conserve the land so that we'll conserve the humanity on this living planet. And the only thing actually is that safe chemistry and the use of the organic matter and use of the lot of microbials. Whatever the system that you want to follow, that is the way that we can go ahead. Thank you. Now with this background, actually we would like to discuss more of the things and all. I thank for everyone for giving me this opportunity.
Thanks, Dr. Rao, for setting up the context. And as you rightly mentioned, there are various components of related to usage of fertilizers, related to usage of chemicals, and many other components. So we'd like to stick to those components and see in next 30-35 minutes what could we discuss and conclude on a specific aspect. So, Dr. Rao, you mentioned about various components which impact the soil health. Which according to you the most important component based on your understanding of last 30 years working with IHR?
Yeah. See, as I already emphasized, actually we have a biological component and a physical component. Physical component I only stick to only organic matter. The organic matter and which contains the humus is the basis ultimately for the soil sustainability and the sustenance. So in this, when we are talking about the biological, so we have knowingly, unknowingly, actually farmers started using so much amount of fertilizers, indiscriminate use of the chemicals. I don't say that the chemicals are bad, fertilizers bad. No, they are required, but judicious use did not happen, and that's why the soil sickness has happened. So this is the main problem now, Manoj. So the soil sickness is rampant. So and about the soil sickness, when we talk about three components mainly: nematodes, fungus, and bacteria. Pathogenic fungi we say, pathogenic bacteria, and pathogenic nematodes. These are all the culprits, which is making the whole agriculture very unproductive, and then making the people to use a lot of chemical pesticides. The chemical pesticides again indiscriminate use, and again I want to emphasize actually we need a safer chemistry. We need a safer chemicals which will help actually, and that is how the whole soil sustainability can work. Soil sustainability is required actually. It's a journey. It's not a destination. So it's a journey. It happens over a period of time, for which actually now we need to do a lot of things actually. Thank you.
So thanks for elaboration. With this context on the three aspects of biological, chemical, and physical matters of soil which impact the soil health, I'll now go to Dr. Naved and would like to understand. Dr. Naved had worked on GAP, globally accepted principles or generally accepted principles on sustainability. So I would like to hear your views on how as a country we can follow the approach at a national level, one, and number two at an individual small farmer level to implement, to take efforts towards ensuring growth or yield at the same time managing the sustainability of our soils. Over to you, Doctor.
Good afternoon, everybody. I believe that with the advent of the technology, the yields, the possibilities, the production systems, the knowledge systems all progress. And with this comes, with the productivity comes the power, and with power should come the responsibility. So when we talk about good agriculture practices, it is about being aware, it is being about responsive, it is being about responsible. So what in informal terms I call GAP is responsive and responsible production system. So when you are reaching the higher level of knowledge, higher level of technology, we have to shoulder the responsibility as a better producer, and good agriculture practices actually help us achieve that. So when we talk in general terms, because many people are not from that background, so as a commoner if I ask about the good agriculture practices, actually these are the 4 pillars of agriculture production system, which takes care of not only the production but also the environment and health. So the 4 pillars, if I say, of the good agriculture practices are economic viability, because every farmer, every producer does it for the economic gains at the end of the day. So it is the economic viability, it is the food safety, it is the environmental sustainability, and of course it is the social acceptability. It is not that you whatever you do and the society will accept, it is not that. And to apprise you in general terms about the good agriculture practices and its effect, suppose in Indian context, if I say, if you go to the market and if you pick up a fruit, would you know where it came from, who produced it, what pesticides were used, when it was harvested, what is the shelf life? So if you can trace it back to the place where it was produced, good agriculture practices are that responsible that they trace the product from the field, from the farmer, from the site to everything. So traceability is the core of this production system. Traceability and transparency, because it takes stock of the site, it takes its stock of the data, who produced it, the sampling, the soil, the water, the plant protection regime, the harvesting regime, the whole crop history and whole site history has to be recorded. So entire record has to be kept, and at the end of the day, then you also have the feedback systems, the audit systems. So the good agriculture practices, they systematize the production system and they make you hold responsible. And of course, the rewards of the good agriculture practices is not necessarily that you will get the higher price for the produce, but of course higher credibility of the produce, and with higher credibility you are likely to get the more this thing. Now in this, to achieve this, every organization has, and every stakeholder has different role. Producer has its role and retailer has its role, and the government institution sets up the bodies, accredits the institutions which will audit it. So the whole ecosystem has to be developed around it. Now in India, there are very few products which are GAP certified, because it is at the higher end of the spectrum of agriculture production system and commerce. But there are several products, for example grape, for example pomegranate, for example mango, which are under GAP certified conditions. In India, most of the buyers are still not at that level of economic freedom and affordable level and awareness level that the demand for the GAP certified produce, but we are exporting many products which are GAP certified. Of course, every country has its own GAP, like India has India GAP, it started in 2011. The GAP headquarters are, the global GAP are in Germany. It was established somewhere in 2005. It had all started from Europe GAP. So this is creating an ecosystem, environment, the system, the answerability, the audit system, which makes overall healthy production system. And of course soil, as we are talking about soil mainly, and of course the pests also, it makes a whole system very dynamic and responsible. So that is about in brief GAP. It's a very big process, easier talked than done. Every component, even a small component like on what we work, integrated pest management, it is just one meager component of like 14 principles of good agriculture practices. I have one technical bulletin. If you will go by my name on the internet, then one whole technical bulletin on GAP and its basic principles can be read and seen. And if you have any queries, we will handle later on. Thank you very much.
Yeah, thanks for giving elaborate view on how GAP help. I mean, just for the benefit of audience and someone who do not understand technical aspect, can you just share one or two real life example where GAP are applied in India Maybe at the extent may be small, but that's fine. But are there any real life example where these principles are actually applied and has benefited as an example?
Yes, yes. If anybody is interested to see the real success stories of GAP happening in India, they can visit the EPITA website, wherein complete traceability chains can be seen for the crops like
Exported.
mango for the export quality. In India, GAP certifications are again routing through the EPITA only. So it is actually buyer who is the god in this entire process. And in countries like India, in some developing situation where farmers are not that well aware and that well ensconced in the whole economic domain, then this is not as well strengthened for Indian markets, because Indian buyers are, you see, when we were young, we were drinking water from anywhere, from any hand pump, any well, that 30 years down the line. Suddenly what happened, that our awareness increased, that it may not be, this water may be good, this may not be good. Then over a period of time, with the development of knowledge and affordability, our affordability increased. Now then the systems are coming, then accreditations are coming, accessibility is coming. Mineral water was not available everywhere 30 years back. So with awareness, with affordability, with accessibility and with accreditability, these systems are coming, and of course we in very near future hope that our production systems will be that well mature economically, scientifically and systematically to achieve those levels.
Yeah. So what I'm hearing, the way mineral water or say safe drinking water is available now, all of us drink bottled water, if I use the correct technical word, bottled water, because accessibility, awareness and another couple of components are improved, and you expect similar things to happen with respect to good principles or generally acceptable principles to be applied in various domains of agriculture, and hence become more operationally viable, right?
Definitely, definitely, that is the desirable thing.
Yeah, thanks.
Most desirable.
So with this setup of specific principles on improving the health of agriculture, I'll go to Dr. Vishal, who is a principal scientist, at IRI, and done a lot of work on related to soil health, and specifically on the technology front. You have published various papers. I want to understand what specific work, like institutes like IRI or any other national or any private institutes, what kind of work they have done on a technology front, biotech front or any technology which has helped our country to address these issues related to soil health.
Thank you, Manoj. So if you recall, the previous generation of insecticides, pesticides that were being dumped into soil, they were all general biocides, right? For example, carbofuran, if you see, it can kill snakes, lizards, frogs, insects, nematodes, everything. So what we are doing right now is, in the past few years, we are developing various platforms, like for example, genomics based platforms, trying to understand the biology of these organisms, how they live, and then two things are coming out of that. The first thing is, we are trying to understand the specific targets within these organisms that can be used to target a chemical molecule, right? This chemical molecule can later be developed into an insecticide. This insecticide will have minimal or almost zero non-target effects, right? So we understand the biology, we find a safe target, we find a metabolic choke point. So these choke points are present only in these insects or nematodes or pathogens.
So can you name 2-3 technologies or intervention happen in last 5, 10, 20 years which has impacted?
So we recently have got a patent. Dr. Uma Rao, she was a scientist in our division. She got the world's first patent on RNA interference. She silenced one particular gene. It's a neuropeptide in a nematode. If you silence that gene, the nematode cannot find its host. So it's very, very safe. It's confusing the nematode and not killing the nematode, and eventually your crop is safe. Okay.
Great.
So this was the first thing. Second is we are using the same information and using it in genetic way. So genetic means, for example, we all are familiar with the BT technology.
Yeah.
So you take a toxin, express it, and it's very selectively killing insects only, right?
Yes.
Similar kind of things are being done by taking RNAi based approach, like we silence a particular gene that is involved in pathogenesis. So the organism cannot parasitize the host plant.
Yeah.
So we are trying to get into a zone where we are using nematode based targets or insect based targets and develop molecules that will be very safe for the environment.
Yeah. So the insecticide or product which is developed, which will impact only the targeted
It will be very
targeted
selective for the
pest,
target.
and it doesn't remain a broad based impacting
Not at
other
all.
thing.
Yeah.
Yeah. So this brings me to one of the point, Dr. Rao, you mentioned about biological aspects. You mentioned about fungus, bacteria, and nematodes, the three elements of biological agriculture which impacts the soil health. Most of us are aware about the nutrient, excess use of fertilizers and many other aspects, but this nematode a little confusing and little known about whether it's a scientific community or whether it's a farming community. So just help us understand how this tiny invisible creature affects the soil health, and is that such a big extent that which deserves a discussion or some action around it?
Yeah. Basically, we all have idea about fungus and bacteria, but then the nematodes, I think, as you rightly said, that not many of us, not many people in the society, they are aware of that. So these plant nematodes, they are there around the root system. They are very tiny. So there are actually animal nematodes, human parasitic nematodes. Everybody knows roundworm. So Ascaris, Dracunculus. So like this roundworms, there are around 5 inches or 7 inches. But here, this is less than 1 mm.
Yeah.
You can't see, just with the normal eyes you can't use. They are microscopic, and we have problems around the root system. So they are evolved in such a way. These nematodes, which are very tiny, so they have one robust, instrument which is called stylet. It's there in the mouth. So it actually punctures any particular root system. Though it is resistant for the fungus, though it is resistant for the bacteria, bacteria cannot go inside particular. Let's suppose a banana. This is resistant to fungus. This fungus cannot go inside, but then the nematode can go inside. So there is nothing like a mechanical barrier.
They enter into the roots.
They enter into the root system.
Okay.
So when they enter into the root system, it makes a hole. It punctures. So through that, it gets inside and it feeds on the root system and it develops. It damages actually the root system very, very badly. And it is unseen enemy. People do not know about that. And the biggest problem is that now we have nematodes actually makes the way for the fungus to go inside the root system, bacteria to go inside the root system. It becomes a disease complex. It's not only fungal disease, or it's not a bacterial disease, or it's not a nematode disease. It becomes a disease complex wherein 2-3 organisms are involved. So it's very difficult for the farmer to understand, and the state department people to really diagnose what exactly is the problem. Is it a nematode or a fungus or a bacteria? But it's a disease complex. The whole approach has to be a little different, because the target is, enemy is actually, the culprit is nematode.
Okay, so great. When you look at soil health, there are I think almost everywhere there are facilities available to do soil testing and know what is the level of nutrients, measure micro. Are there systems available for measuring the extent of fungal and nematode damage, and how pronouncedly they are used?
Yeah, It's a very important that we lack actually in this particular area, because the whole farming community awareness is only around nutrition, NPK levels or the micronutrient levels and all, but then they really do not understand actually the soil sickness. The yellowing of the leaves actually can happen because of the pathogens. They only think it is a nitrogen deficiency. So that awareness has not cropped up actually, and then that's the reason the labs are not there. And the private institutions are catering to the needs of the farmers who are aware, and then they come for the analysis. Yes, soil analysis is done in all the ICR labs and also all the university labs. They give the picture actually what your soil contains, pathogenic bacterial load and pathogenic fungal load and also nematode loads. There are systems which are available. The main problem is that a lack of awareness. Lack of awareness. That is the only issue. As Dr. Naved was very nicely put it actually, the awareness and affordability and all these things and all make the people to get into all these aspects. So the time will come actually when people ask for the nematode density in the crop, and it's required. People should know, and it's a serious problem. Almost around 10,000 crores of crop losses are happening actually in the country, in the whole India. Yeah. So that's a serious problem actually, but people are not aware. Even policy makers, many of them are actually not aware. Even NGOs and all not aware. Common public actually not aware. They only talk about organic farming. They only talk about sustainable farming. So we talk about a precise farming. As Dr. Naved was telling, precisely we should be able to deal the problems of the soil sustainability so that overall sustainability can happen. Thank you.
Yeah, so just to substantiate what you said, I was reading a report by IRI, and it says 19.6% annual crop losses due to plant parasitic nematode. 20% is huge, yeah. And it goes further and says in protected cultivations losses are up to 60%. Is it believable? 60% losses?
It's 100% believable. I have even shown actually two photographs wherein actually in the 1 acre area you could only see the 70% of the completely was affected, only 30% was were remaining actually. So 70% of the tomato crop actually which has got 1 acre 40,000 square feet. Out of that actually 30,000 square feet actually there is no tomato crop at all. There is no capsicum crop at all. There is no broccoli. So that is the level of the damage which is happening because of the nematode, fungal and bacteria complexes. That's the reason. Yeah. So I would like to say that actually the complex the problem is huge. And FPO has already gone into record that actually from the protected cultivation, India is going to contribute tremendously for the water pollution. So there is so much amount of water pollution which is happening actually because of the polyhouse protected cultivations, wherein farmers are not aware, and then the whole system is not, people are not aware. So do they have to, cater the needs of the, fungal management or bacterial management or nematode management? They are confused. So because of this, so the farmers are indiscriminately, desperately, using the, chemical pesticides. Actually, that is the problem. And again, I say actually pesticides indiscriminately when they are used, they are harmful. When they are used actually judicious way, they are not harmful. That is what we call it as a integrated pest management. So that is what is required actually. So ultimately what boils down is that actually the nematodes are serious, and polyhouse cultivation actually is not becoming profitable. And I tell you actually almost around 40 to 50% of the polyhouses have not been used and put to use actually in the whole country. And the soil is not used. They are growing actual crops in the poly bags. Yeah. So aquaponics and then the hydroponics are coming, and the cocoa peat actually they are using actually 30% of the polyhouses in the whole country. So and 30% of the polyhouses are even abandoned. They said we cannot even cultivate it. That is the level of the problem.
Yeah. So I think you made a valid point. I heard and read 90% of the food, maybe more than that, comes from soil. I mean, soil is a source. I mean, it comes from the crop, but the soil is the basis. Still 10% like hydroponic and other thing. So I would loop in Mr. Rajat, who is a CEO of agri-tech company, and want to understand, these veterans talk about biotechnology or agriculture sciences and technology. Want to hear from you how the digital technology can help in this domain on the entire soil health management aspect, Are there any tangible things happening, or there are potentials of things happening of using technology to improve the soil health?
Thank you, Mr. Manoj, for this opportunity. I think we have heard Dr. Rao and Dr. Naved and Dr. Vishal covering the entire topic so far. I would rather start with saying that any solution which is available has to be seen from the viewpoint of affordability, awareness and availability, right? And not just the digital solution, but the digital solution we see has to be coming up with integrated with some hardware based solution which should be highly affordable, very easily to be used by the people on the ground. For example, we have got close to 141 million hectares of the land wherein it is a net sown area wherein we are doing Kharif Rabi cultivation, right?
Yes.
And this huge area is available, and farmer need to see this in certain way, like it should graduate from looking at macro and micro element related answers for the farmer. Then going to solutions which can help them understand about the status of microbes, the healthy as well as bad microbes available in the soil, and then coming to the nematode related solutions which are there. So as far as
are there any tangible solutions available on measuring the soil health with the use of digital technology? It could be any component of soil health.
Yeah, so let me come on that. So basically we have got like NIR spectroscopy based soil testing solution which is basically coupled up with the SAS platform, and that is indeed a digitally integrated agriculture platform, and when you use the hardware you are quickly able to assess the soil nutrient in less than 2 minutes of the time. So that is the stage 1 of the solution, Mr. Manoj. So once you are aware about what is there in the soil, right, then you have to link it with the solutions available which is being provided by the industry stakeholders, and that can be approached through the channel partners and the awareness being created by the industry. And then of course the channel also includes the upcoming FPOs and the supply chain partners who should also join in this initiative to create awareness and use these solutions, so that when the results of these solutions comes on digital interface, it should be used further by the industry in the further supply chain processes. Say if you are aware about a certain geography having such and such soil status, followed by the microbe status, followed by the status of health vis-a-vis the nematode population, then possibly a lot of value can be derived for the farmer as well as for the industry partners.
Are there any technologies currently existing and being used successfully?
Yes, NIR spectroscopy based technology is available in couple of countries globally. In India, we have also brought this solution. So
what it does?
Yes, so it is basically currently able to assess the nutrient status in the soil, right, in less than 2 minutes of the time. And once you do that, it is also mapping digitally. It is helping mapping the soil land, the land of the farmers, and then you also get the results out there digitally in your interfaces, right? So it starts with the hardware wherein you understand the status of the nutrient, you get the result on the interface, and then with the passage of time you put layers on the data and you keep on understanding how the soil is improving vis-a-vis different nutrients as well as the microbes.
So you are talking in less than 2 minutes, knowing the health of my soil, on a digital platform. Is that technology available in India?
Yeah, it is absolutely available. So let me tell you, like currently we have been able to spread to close to 15 states. We are indeed working with a lot of industry partners currently, and that is one initiative which has been taken by us. I'm pretty much sure that the same technology will have further developments, and it will be having further stages of evolution wherein more will be added beyond the status of nutrients. That is what I would.
So you're saying it's available?
It is absolutely available. It is being used currently.
Any farming community can access it now?
Yeah.
Or is there?
Yeah, so certainly farming community can assess when industry is actually using it on the ground. So farming community can actually assess it. So as I just mentioned, so awareness component, right?
Yeah.
Here comes the importance of using digital tool. So let me cite one example. With the advent of 4G and 5G, we all are aware that the consumption of data is very increasingly getting consumed at the level of farmers. On our side, let me just share briefly. We have got a YouTube channel wherein we create certain sort of awareness very organically. We have got more than 80,000 users trying to consume that data. So what I'm trying to say is not just the tech, but awareness of the availability of affordable technology at the ground level to be used by the industry and promoted in a collaborative mode by the industry is only going to ensure the productivity enhancement at the level of farmers, especially the small and marginal ones, and that actually connect all the dots.
Yeah. So thanks for. I hope that's also is affordable as well. That.
Yeah, so as you have asked me a question, so we have been able to brought down the cost of soil testing from 300 to 500 rupees to just 15 rupees in India.
Yeah. So
yeah, that's the change. So any tech which is to be adopted has to be highly affordable and has to be very quickly replicable. So this solution which we have is able to give more than 50,000 tests. Yeah.
Yeah. So looks exciting. 15-20 rupees soil test in 2 minutes on digital. Looks a disruptive thing. Would like to understand more about, and I think there might be few people who would like. So I think it makes sense to explore and check this. Dr. Rao, we spoke so many things can be done. Why the soil is getting deteriorated? Are there any example of public-private partnership or coming together and working on a major project and bringing out some tangible results on sustainability front?
Yeah, certainly. So, Government of India is aware of all these things, and Indian Council of Agriculture Research has been encouraging the multidisciplinary research, also the PPP mode actually in the work projects, and various state agriculture universities also are doing it. So, for example, from IRI, wonderful technologies have gone to a field, particularly in Punjab, where the burning of this particular grass is becoming a serious problem.
Yeah.
So there the technology of IAR actually has gone to the farmers through the industry. So the PPP model actually. And various ICR institutions, this useful microbial cultures, beneficial microbial cultures can be produced in a bigger way in the fermentation systems, and it's only done by the industry. And technology providers are only ICAR and the SAUs actually. From IIHR, the biopesticides, when we talk about biopesticides, we have biopesticides for control of the pathogens, fungal pathogens. We have biopesticides, useful organisms, let me put it actually as useful organisms to control nematodes, and useful organisms to control bacteria, and useful organisms to control the pests. So all these things, and from IIH actually, almost around 550 industrial licenses, licenses actually have taken this technology. And I am happy to inform that actually I have given this 550 industry technologies to the to the industries actually in the country, supposed to be a maximum by any scientist in the world actually. So the ICR has come forward actually with a private and public model actually. So we give the technology and the private producers, and in nook and corner actually of every country actually the ICR has given the technologies for producing the microbial biopesticides which are safer to the soil. Sustainability can happen through the safer biopesticides, safer chemistry, and bringing awareness actually among the farmers. So a lot needs to be done. Still, all these things are happening, but lot needs to be done. The awareness actually in the policy makers also, has to be such that actually the micronutrients, biopesticides need to be given subsidy.
Yeah.
If you talk about subsidy per se, when you don't talk about subsidy, it's okay. When you talk about subsidy, the micronutrients, which are affecting the soils in a great way. The NPK subsidy actually has helped the nation and the farmer, but it has affected our soil in a very, very great way. 80% of the Indian soils actually are deficient from the sulfur and zinc. which are critical. Zinc is not there in the food grain that I am taking it. Even the millets, what we talk actually, the zinc is not available. So where does this resistance comes? So our generation do not have resistance. Zinc tablets had to be given in the corona time. So all these things are happening. So a lot has to happen from the government of India for the biopesticides and balanced nutrition, bringing awareness among the farmers, linking the institutions and private in a great way. Thank you.
Yeah. So I think I'll just with 10 minutes to go, I'll put a last question to Dr. Sabir on this integrated pest management. What are the 3-4 components quickly in a minute before we go and summarize this session?
Since I have already spoken on GAP, and integrated pest management is indeed the part of one component out of the 14 is integrated pest management of the plant protection. Other than the social acceptability, all the rest 3 remaining principles, that is economic viability, food safety and environmental sustainability, are the 3 principles on which the integrated pest management hovers around, and it includes virtually everything from crop planning to harvesting stage, at times even the post harvest stages, and all the pests and diseases. The key is that we have to select those measures out of hundreds of plant protection measures across crops. We have to select key pests. We have to, we are not going to kill the pests. We have to learn to live with the pests, and we have to just keep them below economic threshold levels. So we have to select the measures, and beginning from the planning of the crop, the baseline study of the crop, and synthesizing the plant protection measures and even cultural measures and interventions and mechanicals and physical all measures in such a manner that the pests are kept below threshold level, and you have to keep those 3 pillars in mind: the food safety, the economic profitability of the grower, and the environmental sustainability. So these are the key components of integrated pest management.
So I'll just summarize the discussion so far. We started the topic talking about which are the components. There are biological, chemical and physical components. In biological components, these tiny creatures like nematode causing 20% damage. I think there is a lot of work to be done on awareness and how to manage it. The way in one of the example, one of the panelists mentioned identifying a targeted technology which kills the target pest without impacting other beneficial thing. Then we spoke about GAP, which should include economically viable solution, which are safer for the food, which are safer for the environment, and more importantly socially acceptable one. And as an example, we spoke about export of mangoes and couple of products which is coordinated by APEDA. On technology front, at least I heard for the first time in my life that soil test can be done in 15 rupees. It's a potential possible, maybe some hurdles are there, but 15-20 rupees soil health in a populous country where 13-14 crore farmers are there. I think it's a game changer, disruptive technology, and I wish whoever is doing that luck, because that's going to really change the dynamics how Indian farmer operates. We spoke about the technology. It should be affordable, accessible, and aware. I think the one example which you have given fits the bill. Then we said that government and private can come together, and he has given a couple of examples how it can work. I'd like to end this session because as a panelist, we can always recommend tens of things what government can do or what others can do. I want to end this session with a voluntary question. Any of the panelists who want to come forward and say, okay, this is what I'm going to do for soil health in my capacity as an individual, or as a professional. Any volunteers on that? From us? Yeah. Let's start with us. I mean, we have given enough for others.
You see, when we talk about soil health management, this gamut and the canvas are so big from soil structure, from our very existence, the very surface, very land we are standing upon. There are so many things. There are under managements, there are over managements, there are exploitations, there are disturbed ecosystems. And while they have disruptive technologies like bringing the cost of the soil testing down to some 15 rupees, that is really amazing, which was not achievable even for 300, 500 rupees. Even IRI is doing soil testing just for the nematodes for 1,000 rupees at the moment. Yeah. So that is a game changer. One of the few things that I would expect the industry to come out with is testing for the pollutants, the heavy metals, whether water is safe or not. Even if we get the water from the RO, it may not be free from the dissolved toxicities. Yeah. We are just taking care of the microbes and the big particles and big dust and whatever in common terms we can say. But the dissolved solubilities, so like heavy metals, the pollutants, the dyes, there are innumerable number of things which are there, carcinogens, hidden, the metabolites, the secondary metabolites coming from so many sources. So these are the things that we have to look into, and as integrated pest management scientists, the first thing and foremost thing we do is we try to stay, as Dr. Rao was also telling, the judiciousness. Yeah. You see, judiciousness, what is judiciousness and what is sin? You see, there is in Arabic, there is one very good definition of sin. Crossing the boundary is sin. Even drinking water could be sin. Yeah. If there are 200 people and I drink whole water, it is sin. Yeah. If I kill myself drinking 200 liters of water, it could be sin. So, dredging the boundaries, trespassing the boundaries, the judiciousness of the use of the chemicals, what differs the human beings from animals is this rationalization. Yeah. And even yesterday I was talking about on Global Vertical Farming Forum, and people are talking about that we can produce 100 acre worth of produce from just 1 acre, 10 times to 20 times by virtue of technicality, and 10 by going vertical and by increasing the number of layers. Yeah. But the immediate question that comes to the mind is not the technology. For me, as a sustainable farming scientist with that bent of mind, the immediate question, it is not the answers that are important. Most of the time it's the questions that we put to ourselves which are very important. The question that we put as a policy planner is what we will do with the remaining 99 acres of the land. Yeah. Would we put, now we have an opportunity that we got the produce worth of 100 acres of land from just 1 acre. Yeah. So this is an opportunity to put the rest of the 99 back to the nature, let the nature heal, recover and get some time, respite and cleaning of the environment, or immediately we put another 99 acre into that rigor of this product, this high level of productivity. So greed is nothing but, and then if you extend this logic to the latest book of, maybe most of you must have read, Sapiens. Agriculture itself is like what has led to the greed. Yeah. Before agriculture, nobody was storing. When nobody was storing, they didn't need the house. Okay. When they did need the house, they didn't need the bank. And the whole process of greed has actually started from agriculture. So we have to trade this path of productivity and agribusiness and promotion of it with very high word of caution and rationalization. And until we take the sustainable goals, we put it in place in very harsh manner. One more thing that I spoke yesterday was that anybody who is producing more carbon should pay more for the food. Yeah. They should give him negative black credit card that you first spend from this. So if I go to the market as a farmer, I may get the cauliflower for 1 rupee, but the industrialist who is producing millions of tons of carbon into the nature and carbon dioxide into the nature should pay 1,000 rupees for the same cauliflower. Then only the term. So these compensatory currency mechanisms I am working on this philosophy. Maybe the economic policy makers will talk sense out of me. I am not the qualified person for it, but these are the things. Then green molecules, the compensatory things. So these are the things that are to be looked into before talking about sustainable goals. Sustainable goals are very big word, and the responsibility trickles down in this case. Thank you very much.
So thanks for elaborate view. So what I understood that you in your capacity and expertise you are trying doing and implementing policy changes where this extreme greed or extreme usage won't be affecting. So thanks a lot. I'll go to Dr. Rao quickly. Individual capacity, anything less than 1 minute.
Yes, I have been actually a biopesticide man, a principal scientist retired from Indian Institute of Horticulture Research, coming under Indian Council of Horticulture Research for 30 years. And I still work actually as a campaigner for the sustainable agriculture in India, working for the state departments and also the NGOs and farmer groups and FPOs, KVKs. I support my level, whatever is possible actually to promote the awareness among the farmers regarding the use of the biopesticides and good agricultural practices, and mainly to understand the complexes of the nematode, fungal and then the bacterial diseases so that they save their own crops and give a wonderful crop, wonderful product to the society. Thank you.
So thanks Dr. Rao. So in my personal capacity working with a corporate world while I am doing my business, one of the things we are trying to push and do is how can we educate the farmers around nematodes, in identifying and testing nematodes, and we are exploring some technology, affordable technology where farmer can detect the. So I'm going to work on that and contribute a bit on my part. Now we'll open the session for I think couple of questions. We have 5 minutes. No, we are done. Maybe 1 or 2 questions.
Question to Mr. Rajat. You did mention about the technology which can assess the soil fertility in 2 minutes. Can you name the product? It's available in India.
Yes, sir. It's called Bhu Parikshak.
Pardon?
It's called Bhu Parikshak.
Bhu Parikshak. Okay.
Yes, it has been developed at IIT Kanpur after a deep research of 6.5 years.
Any idea about the cost?
Yeah, it is costing around 85,000 rupees and it is capable to give 50,000 soil samples.
And the fertility status is when you do a lab test, and how is the matching?
Yeah, it ranges between 83 to 96%.
Accuracy.
Yes.
Thank you.
Thank you, sir.
Yeah. Thanks for your question. Any other question? Yes, ma'am.
A rather short comment also with regard to a gap, because that good agricultural practice and global gap has been mentioned several times. So one perspective when it comes to how this can actually be strengthened, and referring also to the discussion that we had on partnerships earlier. So looking at the global gap, how it developed, it actually came from the food processing companies and the importers, who actually said we need to support farmers so that they can reach up to a certain level of quality which is then needed for food processing. So I really think, following now and listening to all the discussions, that this seems to be one of the key aspects of really looking more and more at these strategic value chain food partnerships, because you cannot. And I think this cannot be done anywhere in the world, that you cannot put all the, let's say, responsibility only to the farmers to follow good agricultural practice, but rather going with them. So really this integrating in it, and then having the business on board, who can then guide, let's say, with help of organizations like Global Gap, to work with them, but not alone. So really having, of course, export perspective with APIDA, but then looking back how this is with the production side. That was just came to my mind following on that. Thank you.
Yeah, I think you're right. Only one a segment or aspect working on gap or any technology won't help. I would, Dr. Navid, would you like to add on this?
Thank you. For gap, when I am talking about gap, I recite one Urdu couplet. I will like to translate it. खुदा जब हुस्न देता है नज़ाकत आ ही जाती है. I was drinking, I am the same person, but 30 years back when I was not aware, I was drinking the water. Now I am aware, it is available, it is accessible, and if it is affordable. So when the systems, the Urdu couplet, with beauty comes the grace. So when you have these things, when you are aware, when you can afford, when the systems are available, these things grow with the systems. The question is that we have to support the systems, we have to develop the systems, we have to work with the systems, and with this with development and of the system in professional manner, these things come automatically. And of course, as I said, here buyer is the God. As I said, in India, most of the people are not looking for the GAP certified produce. So, but in developed nations where these things, as I said, availability and affordability, things like that, they are there, so they are demanding. And it was depending upon that demand in the Europe GAP Retailers Association, it was under the pressure from them that this whole system started to develop. So this takes time. With this, it shows the maturity of the production system and the market.
So the way the India, I mean, there are various reports, the way India is moving from a developing nation with a less than, I mean, 2,000, 2,300 per capita to 5,000 by 2023, I expect specific elements and hierarchy coming into picture, and talking from even consumer side or various value chain, talking about demanding very safer, reliable products. Yeah, thanks for your question. And with that, I think I would close the session, and by thanking you all for a patient hearing. Thank you very much.
Another half an hour we are around, so if anybody is interested in
Thank you, our eminent speakers, for such a knowledgeable session. We would now request everybody to join us for lunch outside. The next session would start post lunch. Thank you.